today's video we will start with these questions. So here you can see that 4 questions are given. So let us start with the first one. So it is given that which of the following has more inertia? If you remember, in last class we discussed that inertia and mass are directly proportional. More the mass, more is the inertia. Less the mass, less is the inertia. So in number A it is given that a rubber ball and out of a stone of the same size, which one will have more inertia? So certainly stone will have more inertia. The reason is that its mass will be more. Okay, then next one, number B, a bicycle and a train. So of course the train will have more inertia as its mass is more. And the third one is a 5 rupees coin and a 1 rupee coin. So of course 5 rupees coin, because its mass is more. Alright, then number 2, in the following example try to identify the number of times the velocity of the ball changes. So the statement is, a football player kicks a football and another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. Also identify the agent supplying the force in each case. So we have to say that how many times the velocity has changed. Okay, so the first thing, when the football is a football player kicks the football, so this is the first time when its velocity changed from rest to it got some velocity. Okay, and this force is applied by whom? By the first football player. So you have to mention that the first velocity, in the very beginning the velocity of the football has changed when a football player kicks the football. And here you have to state also, no, identify the agent supplying the force. So who is supplying the force in this case? The first football player. Alright, to another player of his team who kicks the football towards the goal. So again the velocity has changed when the second football player kicks the goal. So who is the agent of force this time? The second football player. Okay, then the goalkeeper of the opposite team collects means of course its speed will be, or velocity will be, of almost 0. So this is the third time when the velocity of the football is changing, and in that case who is responsible for that? The goalkeeper of opposite team. Okay, and the last case, and kicks it towards the player of his own team. So the goalkeeper again kicks the football to the player of its own team. So the fourth case, this is the case where the velocity has changed. This is the fourth time. Okay, and who has changed the velocity? That is the goalkeeper. So goalkeeper has changed the velocity twice. When he collects, then also he has changed. When he is kicking it back, then also he is changing. Okay, the third one, explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Okay, so this is one of the example of inertia. Suppose in a particular tree some old leaves are there, and old leaves generally they are weakly attached with the tree. So when you vigorously shake the tree, the branch of the trees are getting motion. You are shaking, so the branch of the trees are getting motion, but the leaves are not getting motion. But due to their inertia, what they want to do, they want to remain in the state of rest, because initially they were at rest. So inertia means they want to retain their original or initial state. So these leaves will also try to retain its state of inertia of rest, and as a result it will fall. Okay, so this is an example of inertia. Of what kind of inertia? Inertia of rest, because the leaves were initially at rest. Okay, and since they are weakly attached, that is why they will fall down. Otherwise other leaves are also there which are strongly attached, like the new leaves, so those leaves will not fall. The reason, because they are the force by which they are bind with the branch is more. Anyways, number 4. So in number 4 you can see that why do you fall in the forward direction when a moving bus brakes to a stop and fall backward when it accelerates from rest? So this question already we discussed in last video, that this is also here two examples, that is inertia of motion and inertia of rest. It is the example of inertia of motion and inertia of rest, right? Suppose when the person is when we are sitting inside the bus and suddenly the bus applies brake, means when the bus is moving, suppose we are inside the bus, so what kind of inertia we are possessing? Inertia of motion. And when the bus stops, our body still wants to remain in the state of inertia of motion, and as a result what happen is we fall in which direction? We fall in forward direction, okay, forward, when the bus suddenly applies brake. Then next one, when suppose the bus is at rest but suddenly it accelerates, in that case our body was at the state of inertia of rest, but as the bus started accelerating, our body wants to remain in the state of rest, and as a result we move in backward direction. Okay, so this is the example of both inertia of rest and inertia of motion. So I hope it is clear. If you have any doubt regarding any question from this part, you can ask me. Okay, so we discussed first law of motion and we have discussed the questions also. Then we'll move to second law of motion, which is little bit mathematical. Okay, so to understand this in a mathematical way, let us learn some more things about it. So what is that? Okay, very simple things. I'll give you a few examples. Suppose in this law you will get a term called momentum. This one, momentum. This one, momentum. Now first of all you have to understand what is momentum. Suppose this object is there and the object is having a mass of m, and the object is moving, not at rest, moving with a velocity or speed v. Then its momentum will be m into v. So what is momentum? It is the product of mass and velocity of an object. So if momentum is the product of mass and velocity, we can write it like this. P is the representation for momentum. So P is equal to m into v. Right? Now momentum has both direction and magnitude, because direction, why it is having direction? Because v is velocity. Velocity is a vector term. Vector means what? It has direction. So since velocity has a direction, this product of velocity and mass will also have a direction, and magnitude of course it will have. So that means momentum has both direction and magnitude, so it is also a vector quantity. Okay, now see, SI unit of momentum is kilogram meter per second. Why so? Suppose for mass, what is the unit of mass? Kilogram or kg. Okay, and what is the unit of v, velocity? Meter per second. So what is the total unit then for momentum? Kilogram meter per second. That's what is written here, kilogram meter per second. Okay, we can write it in this way. Under bracket it is written kilogram meter per second, means s to the power minus 1 also we can write, or you can write m meter per second in this way also, and kg will be there. Okay, so this is the SI unit of momentum. Now I guess you have understood what is momentum, and once you have understood what is momentum, I will tell you another thing about it, about momentum only. Physically momentum means it is the impact created. Listen carefully what I am saying, that momentum is the impact created on an object by another object. Suppose for example a bullet is fired from a gun. So the bullet is having very less mass is in the order of few grams. It is a small object, bullet, but the impact created by the bullet is large. Even it can cause death of a person, right? The impact is much more than as compared to its mass. Why the impact is more? Because its momentum is more, And how come its momentum is more? Though its mass is less, its velocity is very high. When it is fired, it has got a very high velocity. So if velocity is very high, when you take the multiplication, mass into velocity, so velocity is contributing, right? So that means it has a larger value of momentum. A bullet having less mass but its velocity is large, as a result the product is a large value. So that means a bullet is having a very large value of momentum, and that is why the impact created by the bullet is very high. Suppose, for an example, if you take the bullet and if you simply throw it with your hand, will it create that much impact? No, right? The reason is that it has got a less velocity. It will get a less velocity if you throw it simply with your hand. So since velocity is less, its momentum will be less. That is why it will create less impact. So in simple word, momentum is the impact created by an object on another object. Okay. Similarly, suppose a huge truck is there, and if the huge truck, or if a person met with an accident with a huge truck which was not moving with a very high velocity, still the impact created on the person will be large. The reason is that the truck was huge, so its mass was more, though its velocity is less but mass is more. So when you do the product mass into velocity, the product will be more only. So if it has got a large value, that means momentum is more, and if momentum is more, the impact created by the truck will be much more. Okay, so I hope you have understood the concept of momentum. Then we will proceed to the second law of motion. Okay, this one, mathematical formulation of second law of motion. So as I told you that in this chapter we are dealing with three laws. The first law is the law of inertia. In fact, in last video I told you the statement also, and it is better if you write down the statement. Okay, whatever I said in the last video about the statement, you can note it down. In fact, in this law also it will have a statement. So I'll tell you the statement first, and then I will make you understand the statement. Okay, so first of all, how you will write that state second law of motion? You have to write that it states that the force applied on an object is directly proportional to the rate of change of momentum of the object. This is the statement. It states that the force applied on an object is directly proportional to the rate of change of momentum of the object. Okay, now suppose I will explain this statement. Suppose initially means at the beginning, an object we have, and the object is having a mass of m, which is moving in a straight line with initial velocity u. Mass is m, initial velocity is u. What is its momentum then? Isn't it mu, mass into velocity? So this will be considered as the initial momentum, because this is the initial velocity. Okay, initial momentum. Now what happened is, some force is applied on the object F. For how much time? For time t. And when force is applied, certainly the velocity of the body will change. Initially the velocity was u, now the velocity has become v. I hope it is clear. Initial velocity was u, final velocity after application of F force becomes v. So what is the final momentum? Final momentum will be mv. Initial momentum was mu. Alright, what is the change in momentum? One more thing here they have mentioned here. Suppose, to make it little short, they have mentioned it like this: p1, p means momentum, p1 means initial momentum, which is mu. Okay, and p2 means what? Final momentum, which is mv. And why this momentum has changed? Due to application of a force which is F, for how much time? For time t. So how much is the change in momentum? change. Change means final minus initial. So if you do final minus initial, then according to the statement that I told you, that force applied is what? Directly proportional to the change in momentum. So force applied, suppose F, is directly proportional, this is the sign, this one, directly proportional to what? To the rate of change of momentum. That's what I said, to the rate of change of momentum. So what is the rate now? That means force is directly proportional to the rate of change. Rate means first we will write the change in momentum. Change in momentum is how much? mv minus mu, and rate means divided by time. And this is this equation what I have written here. Okay, I hope it is clear. According to the statement, just now I told you the statement of second law, that force is directly proportional to the rate of change of momentum. How much is the change of momentum? mv minus mu. And what is the meaning of rate? rate. Rate means divided by time. Okay, so this is the mathematical way to explain or to write the second law of motion, and this is what written here. Okay, now the question is that how we can modify this. Remember that always when we remove this proportionality sign with an equal sign, we multiply the whole thing with a constant k. Till now we don't know what is the value of constant k. I will tell you the value, but for this time being we will keep it as k itself. Okay, k is a constant, and this is the rule. When we change this proportionality sign with equal sign, we multiply the whole thing with the constant k. The rest thing will remain as it is, mv minus u. And how did this value came? I think you understood. Just now I wrote this one, no? F is equal to what? mv minus mu by t. So from this two term we can take m common. So what will remain? V minus u. So that's what is written, m common, v minus u. Okay, then next step, I hope you remember v minus u, v minus u by t is what? It is acceleration, isn't it? In last chapter you got. So in place of v minus u by t, we are writing a, acceleration. K will remain as it is, m will remain as it is. Now I will tell you the value of k, and for that, to get the value of k, experimentally it is found. Okay, theoretically we cannot get the value of k, but experimentally it is found that when the value of this force is 1 Newton, okay, Newton is the unit of force, huh? Remember that Newton is the unit of force. Alright, so suppose on an object 1 Newton force when it is applied on the object of mass 1 kg. We have an object like this, and the mass of the object is how much? 1 kg. How much force we have applied on the object? 1 Newton. The object will undergo some acceleration, right? And how much the acceleration is? It is found that the acceleration is also 1 meter per second square. So if it is so, force is also 1, mass is also 1, acceleration is also 1. So this force is 1, mass is 1, acceleration is 1. What is the value of k then? Isn't it 1? The value of k is also 1. So experimentally it is found like that the value of k is 1. And how it is 1? Because when an object of 1 kg mass, or when on an object of mass 1 kg we apply a force of 1 Newton, the acceleration of the object becomes 1. So when all the terms becomes 1, then obviously k will also be 1. And once k is 1, what will be the shape of the formula? F is equal to ma. Alright, k will be 1. So this formula we got, F equals to ma. M means mass, a means acceleration, F means force. So this is the mathematical form of second law of motion. Okay, then an important thing is that from this part, define 1 Newton force. There may be a question that define 1 Newton force. So how will you state? 1 Newton force means this force, right? Define 1 Newton force. The value of this force has to be 1 Newton. So can we state it in this way, that 1 Newton is the force which produces an acceleration of 1 meter per second square for an object of mass 1 kg. Suppose if mass of this object is 1 kg, if acceleration of the object is 1 meter per second square, then what is the force? Because force means mass into acceleration. So mass is 1, acceleration is 1. If you do the multiplication, how much we are going to get? 1 only. So that force is how much? 1 Newton. So in reverse way, we can say that 1 Newton is the force. If somebody asks you that define 1 Newton, you will say that it is the force applied on an object of 1 kg mass to create an acceleration of 1 meter per second square on it. Okay, remember the definition, important one. Fine. So we discussed up to this point. Okay, another thing I'll just tell you from this formula only. Just now you got this formula, right? I'll discuss about this activity also, I mean this fact also, but before that I'll just tell you one more thing. This one. So just now we got this formula, right? F equals to ma, or we got this also, no? F equals to mv minus u by t. So just changing the side, when this t is taken this side, what it will be? F into t. So F into t means we get this formula. Now in this formula, this term ft, it is called impulse. Impulse. I-M-P-U-L-S-E. Impulse. So impulse is the product of force and small time. This time is a small time, ft. And from this formula it is clear that impulse is equal to change of momentum, because mv is what? Final momentum. mu is what? Initial momentum. So impulse is the change in momentum of an object. Remember this term, impulse. Now suppose if ft is impulse, what is the SI unit of impulse then? F means what? Force. Unit of force is what? Newton. And T for time, unit of time is second. So what can be the unit of it? Newton second. Newton second is the unit of impulse. Alright. So this is all about second law of motion. Another thing, see, from this formula one very important fact is established, that force and time are inversely proportional. Inversely, why? Time is down, no? Time is down. So that is why it is inversely. Now what is the meaning of inversely proportional? If one increases, the other decreases. That is the meaning. Suppose if time increases, force decreases. If time decreases, force increases. That is the meaning. They are inversely proportional. Now with this concept, we will discuss about this activity. So here it is seen that when a cricket player catches a ball, he or she pulls down his hand in this direction. When he is or she is catching the ball, what he or she does? Pulls the hand in downward direction. What is the reason? That means this person is giving more time to the ball to get stopped. If the person does not pull his hand down, if the person keeps his hand here only, then the ball will stop as soon as it reaches the hand of the person. And if it is so, the time to stop the ball is very less. And just now I told you that as force and time are inversely proportional, If the time is very small, force, that means the ball will exert more force on the hand of the person, so the person will get hurt. But in the reverse case means if the person is pulling down his hand in downward direction, the person is giving more time to the ball to get stopped. And in that case, when the person is giving more time, then what will happen? More the time, less is the force, so the person will get hurt less. Okay, the force applied by the ball on the hand of the person will be less. Alright, so in this video this much is enough. Then in next video we will discuss about third law of motion and few sums. Okay, thank you.